This PowerPoint presentation video is going to be over the math for disinfecting a well. As a preface, I do not own any of the questions or material presented in this video, as it would all sourced off the open internet. I have, to the best of my knowledge, presented the proper formulas and the correct answers. This is a study guide and for educational purposes. If this helps you learn, that's great. Something a little different with this video, I'm not going to have a formula sheet page. Well, except for this page that says formula sheet. If you have been practicing your math, you should already have a formula sheet from your state agency. If not, I suggest you find it. I'll leave a link to a video where I talk about formula sheets. I still, however, will be solving the problem with formulas step by step. Sound fair? So let's get into the first question. A well is to be disinfected with 62% calcium hypochlorite. The well is 328 feet in depth and 1.5 foot in diameter. Depth to the water from the top of the casing is 60 feet. If the desired dose is 75 milligrams per liter, how many pounds of calcium hypochlorite are required? First, we're going to pull our known and our unknowns out of this question. So what we know is the diameter is 1.5 feet, the depth of the well is 328 feet, the depth of the water is 60 feet, the dosage is 75 milligrams per liter, the purity of the hypochlorite is 62%, and what we don't know is how many pounds of calcium hypochlorite are going to be required to disinfect this well. So our unknown lets us know that we are going to be doing a pounds formula. The 100% purity is dosage milligrams per liter times flow million gallons a day times 8.34 pounds a gallon. Guess what? The purity is not 100%. So if you practice the Davidson pie chart, you'll know what we need to do next. If not, I'll explain. The Davidson pie chart states that if it's not 100% pure, you will divide by the purity as a decimal. So it goes on the bottom. So now we have our formula that's complete. So now we need to see what units we have in our known. We have our dosage. Flow is interchangeable with volume. That's all it is. Well, we don't have volume, but we have things that can help us calculate our volume because we have the depth of our well and we have the diameter. So that means this is going to be volume of a cylinder. The formula to calculate volume of a cylinder when given diameter is 0.785 times diameter squared times the height. So now we're going to find our dimensions so we can calculate the volume of our well. So here we have a visual representation of our well. The diameter is 1.5 feet and the depth is 328 feet. So we're already given the diameter, so we can plug that into our formula. So you have 1.5 foot squared. Now we need to find the height of the water. So they told us the total depth of the well is 328 feet and that the water is 60 feet from the casing, so from the top. So you have 60 feet of empty space. So we're going to have to subtract that 60 feet from the 328 feet depth of the entire well. So you have 328 feet minus 60 feet, and that gives you a water level of 268 feet. So now we can plug that 268 feet, that's going to be the height of our water, into our volume formula. So 0.785 times 1.5 foot squared times 268 feet. So you do your multiplication. You end up with a volume of 473 cubic feet. Now we need to convert that to gallons. There are 7.48 gallons in a cubic foot. So we're going to multiply the 473 cubic feet by 7.48 gallons over 1 cubic foot. Your cubic feet and foots will cancel out, and it's going to leave you with gallons. You do your math, you're left with 3,538 gallons. Now, our pounds formula wants our volume in million gallons, so we're going to have to convert this to million gallons. There are 1 million gallons in an mg million gallon, so the gallons will cancel out. All right, you're going to do your division, and that's going to leave you with 0.003538 mg. So now we can plug that into our formula. So you have a dose of 75 milligrams per liter times the volume of 0.003538 million gallons times 8.34 pounds per gallon. We're going to divide that by the percent purity as a decimal, so divide it by 0.62. So let's do our multiplication on the top first. And I got 2.21. So now we're going to divide that by the purity as a decimal, so divide that by 0.62. And your answer is rounded off to 3.56 pounds. So that was what, like 7 or 8 steps to solve for this one problem? When you break down the math into its basics and realize it's all just building blocks to answer this question, it's not so bad. So if you know where to start, we can figure out how to get to the end. Let's get into another question. How many pounds of 5% hypochlorite will be needed to disinfect a 12-inch diameter well that is 280 feet deep with a static water level of 130 feet to a dosage of 50 milligrams per liter? First, we need to pull our known and our unknowns out of this problem so we can keep track of all the variables. What you know is the diameter of the well is 12 inches, the depth is 280 feet, static water level is 130 feet, the dosage is 50 milligrams per liter, the percent purity of the hypo is 5%, and we're looking for pounds of hypo. So again, the unknown lets us know what formula we're going to start with. We're starting with the pounds formula, 100% purity, dosage milligrams per liter times flow of million gallons a day times 8.34 pounds. Now remember, it's not 100% pure, so we go back to the Davidson pie chart. Davidson pie chart states if it's not 100% pure, you divide your answer by the percent purity as a decimal. So now this is our starting formula again. We have our dosage. We do not have our flow/volume, so we're going to have to figure that out again. Again, we're given diameter, so that makes this a cylinder. To calculate the volume in cylinder when diameter is given, it's 0.785 times diameter squared times the height. Again, here is a visual representation of our well. It is 280 feet deep, and it is 12 inches at the diameter. So we're going to have to convert our diameter into feet because all of our volume formulas in water, cubic feet, so you need feet. 12 inches times 1 foot over 12 inches, so the inches will cancel out. You end up doing division. You get 1 foot, so we can put the 1 foot into our volume problem for diameter. The other variable they have given us in this math problem is the static level, or the distance from the land surface to the water in a well when the water pressure in the well is equal to the pressure of the surrounding groundwater. Essentially what that means is there's empty space between the top of the well and the water level, so therefore it's not 280 feet of water. So we can calculate out what this is. So you have a 280 foot well, but there's a 130 feet empty space from that in the surface. To get the total height of the water, we're going to subtract 130 feet from 280 feet. So 280 feet minus 130 feet, that means you have 150 feet is the height of the water in your well. We can plug that into our formula now. So now we can solve the volume. Let's do our multiplication. 0.785 times 1 foot squared times 150 feet. And that gives you a volume of 117.75 cubic feet. Now we need to convert this to gallons. There are 7.48 gallons in a cubic foot. So 117.75 cubic feet times 7.48 gallons over a cubic foot. Cubic feet cancel out. You're going to be left with gallons. That means we have 881 gallons of water in this well. For the pounds formula, the volume must be in million gallons. So we're going to have to convert 881 gallons to million gallons. There is 1 million gallons in 1 mg. So you're going to do division. Your gallons are going to cancel out. You're left with a volume of 0.000881 gallons. Now that we have it in the correct units of measurement, we can plug everything into our formula. So we have 50 milligrams per liter on the dosage times the volume of 0.000881 million gallons times the standard of 8.34 pounds per gallon. We're dividing that by the percent purity as a decimal. Let's solve for the math on the top first. So when you do the math on the top, all your multiplications, you get 0.3674. Now we're going to divide that by the percent purity as 0.05. And our answer is 7.35 pounds. So this is basically just a volume problem and a pounds problem. It's pretty easy. Let's get into another one. A newly installed well must be disinfected. The well is 750 feet deep and the water level is 115 feet below the well casing. If the well casing is 14 inches in diameter, how many pounds of 65% HTH must be added to the well to reach a dose of 100 milligrams per liter? As always, let's get started with pulling our known and unknowns out of our word problem so we can keep track of them. What we know is the diameter is 14 inches, the well depth is 750 feet, the water level is 115 feet below the ground, the dosage is 100 milligrams per liter, the purity is 65%, and what we don't know is how many pounds of HCH. Again, your unknown lets you know what formula you want to start with. Pounds formula at 100% purity, dosage milligrams per liter times flow or volume in million gallons times 8.34 pounds per gallon. It's not 100% pure. So again, when it's not 100% pure for a pounds formula, you divide by the percent purity as a decimal. So to solve now, we already have our dosage, we need our volume. Again, we're given diameter, so this is a cylinder. Volume of a cylinder, 0.785 times diameter squared times the height. So let's take a look at our well. It's a 14-inch diameter and it's 750 feet deep. First off, we're going to have to convert our 14-inch diameter into feet because all volume problems for water mass solve for cubic feet. So 14 inches times 1 foot over 12 inches, your inches will cancel out. You'll be left with feet. So you do your division. I rounded that to 1.17 feet. So we can plug that into our formula and we're going to have to find the height of our water. So our problem states that the water level is 115 feet below the casing, so the surface. So you have a well that's 750 feet deep. There's a space of 115 feet from the ground to the level of the water. So to find the height of your water, you're going to subtract 115 feet from the 750 feet. So 750 feet minus 115 feet, and that gives you 635 feet. So now we can plug that into our volume formula. You have 0.785 times 1.17 squared times 635 feet. That gives you a volume of 682.36 cubic feet. Again, we need gallons. There are 7.48 gallons in a cubic foot, so 682.36 cubic feet times 7.48 gallons over a cubic foot. Your cubic feet will cancel out. It's going to leave you with gallons. You do your multiplication, you're left with 5,104 gallons. Again, our pounds formula needs the volume in million gallons. So we're going to do our next conversion. There are 1 million gallons in a mg or million gallons. So it's going to be division, so your gallons cancel out. So 5,104 gallons divided by 1 million gallons. Gallons cancel out. And you're left with a volume of 0.005104 mg. So now we can plug this into our formula. So you have a dosage of 100 milligrams per liter times the volume of 0.005104 million gallons times 8.34 pounds per gallon divided by the purity as a decimal, 0.65. So let's do the multiplication on top first. You get 4.26. Now we're going to divide that by the percent purity as a decimal, so 4.26 divided by 0.65. And that leaves us with an answer. We're going to round it and call it 6.6 pounds. So that's 3 questions on solving for the math on disinfecting a well. It's pretty simple. It's a pounds formula, a volume problem, and some conversions. You need a little bit of well terms to be able to do it, but other than that, it's not too bad. So hopefully this video helps you learn. Thanks.